walking into a hospital to get complex open heart surgery.
Oh boy.
Right. A procedure where a surgeon literally has to crack open your chest, stop your heart, reroute all your blood flow through a bypass machine, and then, surgically repair the organ.
Just a casual Tuesday.
Exactly. But here's the kicker. You recover, you're discharged, and the final bill you receive is, it's actually less than the price of a used laptop.
I mean, that sounds completely impossible, right? Like, based on the economic models we're used to in the West anyway.
Yeah, totally.
We've been completely conditioned to believe that advanced solutions inherently require just, massive amounts of capital.
Well, welcome to today's deep dive. If you're listening to this, you are probably someone who tracks technological trends, and you know that our sort of default assumption about innovation is that it relies on addition.
Right.
Like, we assume progress means more features, more processing power, more complex supply chains, and naturally, a much higher price tag.
Yeah, we equate innovation with accumulation. Like, if you face a massive global problem, the traditional Silicon Valley or corporate R&D approach is to basically build a bigger, more complicated, more expensive machine to solve it.
But we are pulling from a stack of research today that completely inverts that logic.
Yeah, it really does.
We're unpacking this really fascinating academic paper by Anthony Kuo titled Harnessing Frugal Innovation to Foster Clean Technologies. And we're pairing it with a comprehensive textbook chapter simply titled Frugal Innovation.
A great pairing, honestly.
So the overarching mission of this deep dive is to explore this kind of counterintuitive reality, how doing significantly less can actually achieve exponentially more.
And, to really grasp the mechanics of this, we have to look outside traditional innovation hubs. We have to travel to emerging markets.
Yeah.
Because in environments with severe resource constraints, necessity isn't just the mother of invention. Necessity acts as the strict, unrelenting editor of invention.
The strict editor, I like that. That frames the conversation perfectly. Let's establish the baseline terminology, though. The sources focus on the concept of frugal innovation, which you might also hear referred to as jugaad in India, or just more broadly as constraint-based innovation.
Right, yeah.
Historically, this originated out of the need to serve what economists call the bottom of the pyramid. So we're talking about populations with minimal purchasing power, living in areas lacking fundamental infrastructure. So no reliable power grids, no paved roads, no clean running water.
Right, which forces a complete paradigm shift in product design. You can't just tweak things.
So I do want to challenge the perception of this right out of the gate, actually.
Go for it.
Because when the average consumer hears the word frugal applied to products designed for people with basically no purchasing power, the immediate assumption is compromise.
Oh, absolutely.
Like, it sounds like a polite corporate term for making cheap, low-quality knockoffs. So is this just, I don't know, the dollar store version of a legitimate product?
See, that is the most common and perhaps the most dangerous misconception about frugal innovation. It's entirely incorrect.
Okay, so what is it then?
Frugal innovation is not about using inferior materials or just stripping away quality to hit a substandard price point.
Mm-hmm.
The core philosophy is about distilling a product down to its absolute, non-negotiable fundamental need. The sources actually tie this directly to the philosophical principle of Occam's razor.
Oh, right, the law of parsimony.
Exactly.
The idea that among competing hypotheses or solutions, the one with the fewest assumptions or the fewest moving parts is generally the correct one.
Precisely. So frugal innovation applies Occam's razor to industrial design. You aren't building a cheap version of a complex machine. You're fundamentally rethinking the machine to eliminate the complexity entirely.
Wow, okay.
And this isn't just a strategy for developing nations, by the way. Look at the consumer technology we consider premium today. Think about before the iPhone.
Oh, yeah.
The smartphone market was dominated by devices with massive physical keyboards and like a dozen peripheral buttons.
The BlackBerry era. I mean, the assumption back then was that power users needed more physical input methods.
Right, but Apple applied frugal thinking. They asked what the fundamental need of a mobile communicator actually was.
Just to interact with the screen.
Exactly. The need is to interact with the software. So they ruthlessly stripped away the physical keyboard, the trackballs, the styluses. They didn't make a cheap phone, obviously.
Definitely not cheap.
No, but they applied constraint-based design to create an elegantly simple, hyper-focused user experience.
That is a great reframe. It shifts the focus away from the price tag and places it entirely on that relentless focus on the essential.
Exactly.
Which I think brings us back to that jarring open heart surgery statistic from the intro.
Oh, the Narayana Health Hospital, yes.
Right, because stripping away physical buttons on a phone is one thing, but applying parsimony to life or death medical procedures, that's where this concept really proves its structural integrity.
It is. So let's examine Narayana Health in India, which was founded by Dr. Devi Prasad Shetty.
The numbers here are just staggering. They perform complex heart surgeries for around $2,000.
It's wild.
For context, in the U.S. healthcare system, that exact same surgical intervention ranges from $20,000 to well over $100,000.
Easily.
And the Wall Street Journal actually referred to Narayana Health as the Henry Ford of heart surgery because they utilized an assembly line model.
Right, so they applied frugal innovation to the human capital side of the surgical process. Instead of the traditional Western model, where a highly paid senior surgeon oversees and executes nearly every single aspect of a patient's journey, Narayana broke the surgery down into distinct, hyper-specialized tasks.
So I have to admit, looking at this from a patient's perspective, the phrase assembly line heart surgery triggers immediate alarm bells for me.
Oh, for sure. It sounds terrifying.
If I'm the one on the operating table, treating my cardiovascular system like a Model T Ford seems like a recipe for cutting corners. Doesn't that mass production model inherently degrade the quality of care?
It's a completely logical concern, but the data actually points to the exact opposite conclusion. This raises a really important question about the relationship between repetition and quality.
Okay.
According to data from the American College of Cardiology, this high-volume, highly segmented approach mathematically increases the quality of the surgical outcomes.
Really?
Yeah.
Because they're building intense motor memory, I guess.
Exactly that. When a medical professional is restricted to one specific procedure, they achieve a level of mastery that a generalist simply cannot reach.
Makes sense.
The textbook highlights a surgeon at Narayana, Dr. Colin John. Over his career, he performed 4,000 complex surgeries, specifically for a condition called tetralogy of Fallot.
Which is a remarkably complicated congenital heart defect. I mean, we're talking about 4 simultaneous structural abnormalities. There's a hole between the lower chambers, an obstruction from the heart to the lungs, an overriding aorta, and a thickened right ventricle.
Right, it's no joke.
Fixing that requires intense microscopic precision to reroute the cardiovascular flow.
And a typical Western pediatric surgeon might only encounter that specific combination of defects a handful of times in a decade.
Wow.
Dr. John did it 4,000 times. Because of this extreme repetition and, the elimination of extraneous tasks for the lead surgeons, Narayana's mortality rate for coronary artery bypass grafting is 1.4%.
Compared to the U.S. average of 1.9%.
Exactly.
So they have effectively decoupled quality from cost. They achieved a higher survival rate for a fraction of the price just by identifying the fundamental need, which is hyper-specialized surgical skill, and stripping away everything that distracts from it.
That is the absolute essence of frugal innovation applied to a process.
Fascinating.
But what happens when the constraint isn't just human capital, but the physical infrastructure itself?
Ooh, this transitions perfectly to another medical breakthrough highlighted in the research. We need to look at the crisis of premature births.
Yes, the embrace warmer.
Right. Globally, there are about 15 million premature babies born every year, with the vast majority in Asia and Africa. And the immediate fundamental biological threat to a premature infant is thermoregulation.
Because they just lack the body fat to maintain their own core temperature.
Exactly. The standard Western technological solution is the neonatal incubator. And, it's undeniably a modern marvel, but it costs upwards of $20,000.
And more importantly, it requires a perfectly stable, uninterrupted supply of grid electricity, not to mention highly trained technicians for maintenance.
Which makes it functionally useless in a rural clinic in sub-Saharan Africa or rural India.
Right.
Like if you place a $20,000 piece of sensitive medical equipment in an environment with rolling blackouts and no replacement parts, it quickly becomes a very expensive plastic storage box.
The environment literally rejects the technology.
Yeah. So a team of graduate students from Stanford University approached this problem through the lens of frugal innovation. They realized the incubator was completely over-engineered for the specific constraints of the developing world.
So what did they do?
They created the Embrace infant warmer. They applied Occam's razor to the incubator. They stripped away the digital displays, the electronic vital monitors, the alarms, and the mechanized airflow systems.
Just taking it all out.
Right. They distilled the problem down strictly to temperature regulation. The physical product essentially looks like a small, insulated sleeping bag.
But the innovation is in the heating mechanism, right?
Yes. They utilized a phase change material.
And for those unfamiliar, a phase change material isn't just like standard wax. It's a substance specifically engineered to absorb and release thermal energy during the process of melting and freezing.
Right. It utilizes latent heat.
Exactly. When you heat this material, it melts, and as it slowly solidifies over several hours, it releases heat at a highly specific, constant temperature.
In this case, exactly 35 to 37 degrees Celsius.
Perfect body temperature.
Exactly. So a nurse or a parent simply takes this pouch of phase change material, drops it into boiling water to melt it, and then slips it into the compartment of the sleeping bag.
That's brilliant.
It acts as a reliable thermal battery, maintaining the precise core temperature required for a premature baby for 4 solid hours without requiring a single watt of grid electricity.
It just bypasses the broken infrastructure entirely.
Yes. And guess how much the manufacturing cost of the Embrace warmer is?
I know this one, but say it for the listeners.
Roughly $25.
$25 versus $20,000. It's just a profound example of how aggressive simplification solves systemic problems.
It really is.
Which naturally leads us to the next massive systemic problem addressed in Anthony Kua's paper, which is the environment.
Okay, yeah.
Because think about it, if we can bypass a broken grid to save an infant, can we utilize constraint-based design to accelerate clean technology?
The clean tech dilemma. I mean, this is arguably the most pressing economic challenge of our generation.
Yeah, without a doubt.
Clean energy technologies like solar arrays, wind turbines, advanced LED infrastructure, they have a severe adoption bottleneck. They are incredibly capital-intensive upfront.
Right. And to bridge that gap, governments typically intervene with massive financial subsidies to artificially lower the market price and drive adoption.
Which is great in theory, but it creates a really fragile ecosystem.
Very fragile.
The moment a national economy enters a recession or a political administration changes or deficit spending just becomes unpopular, those subsidies evaporate. And the entire clean tech sector just stalls.
Exactly. For clean technology to be truly sustainable, it has to survive market forces without relying on artificial government support.
Enter Frugal Clean Tech. The research highlights this amazing initiative called A Liter of Light from the My Shelter Foundation in the Philippines.
Oh, this is such a cool example.
Right. The environmental constraint here is urban density. In the slums of Manila, the housing structures are packed so tightly together that there is virtually no space for windows. So even at high noon on a cloudless day, the interiors of these homes are in pitch black darkness.
So the residents are forced to find alternative lighting. And because the Philippines has notoriously high electricity rates, they often resort to illegal, makeshift electrical taps into the municipal grid.
Which results in exposed wiring that frequently arcs and sparks, causing devastating fires that can literally level entire densely packed neighborhoods. It's a cascading failure of infrastructure.
So what's the frugal fix?
The frugal solution to this is called the solar bottle bulb. It is beautifully simple. You take a discarded transparent plastic soda bottle, you fill it with purified water and a small amount of bleach. Then, you cut a hole in the corrugated metal roof, insert the bottle halfway through, and seal it with a cheap local resin.
And the physics behind it are what make it so effective. It relies entirely on refraction.
Exactly. If you just cut a hole in the roof, you get a harsh, directional beam of sunlight that illuminates one tiny spot on the floor.
Like a spotlight.
Right. But the water inside the bottle acts as a lens. When the directional sunlight hits the exposed top of the bottle, the water refracts the light, bending it and scattering it 360 degrees, providing ambient light to the entire room.
And the bleach.
The bleach simply prevents algae from growing in the water, keeping the lens clear.
The efficiency metrics on this are just remarkable. It requires about 5 minutes of labor to install. The material cost is roughly $1. And a single bottle produces the ambient light equivalent of a standard 55-watt incandescent bulb.
55 watts of completely off-grid, zero-carbon lighting for $1. The Foundation reports this has spread to over 15 countries with hundreds of thousands of installations.
It solves the immediate need for illumination, eliminates the fire hazard of illegal wiring, and removes the carbon footprint entirely.
It's just genius.
And we actually see a similar application of basic physics in Tibet, but shifting from light to heat.
Oh, the solar cookers.
Yeah. The Tibetan Plateau presents a unique set of constraints. It's highly elevated, remote, and very cold. Importing fossil fuels is prohibitively expensive, and electrical infrastructure is just sparse.
Right.
Consequently, the local population relies on burning dried yak dung and scarce wood for cooking and heating.
Which creates a twofold environmental disaster. Burning biomass indoors causes severe respiratory illnesses, and aggressively harvesting the limited timber leads to rapid deforestation and desertification in a highly fragile ecosystem.
But the region has one abundantly free resource:
Sunlight.
high-altitude solar radiation specifically. They average around 3,000 hours of sunshine annually. So the frugal intervention here didn't involve importing expensive photovoltaic panels. Local researchers introduced basic solar cookers.
These are essentially large, highly reflective, parabolic metal mirrors, right? It's pure geometry.
Yep, geometry at its finest.
The curved surface of the parabola is designed to catch parallel rays of sunlight across a large surface area and reflect all of them onto a single, concentrated focal point suspended in the middle, which is where you place the cooking pot.
And by concentrating that solar radiation, the focal point easily reaches temperatures between 65 and 400 degrees Celsius.
Nah.
It can boil water and cook meals rapidly. And once the initial inexpensive purchase of the metal mirror is made, the energy is entirely free. The data indicates that a single solar cooker saves a family approximately 3 tons of dung and 2.5 tons of wood every single year.
3 tons of dung. That is a massive reduction in biomass reliance.
Incredible, right?
So we've established that manipulating basic physics, refraction for light and parabolic concentration for heat, can bypass massive infrastructural hurdles. But both of those solutions rely on the direct presence of the sun.
True.
What happens when the constraint requires active, sustained intervention, like the need to keep something cold 24 hours a day?
This brings us to a fascinating case study in the Indian appliance market.
The refrigerator problem.
Exactly.
So the refrigerator adoption rate in India was stagnating at around 8%. Godrej, which is a major Indian appliance manufacturer, initially approached this as just a standard pricing problem. They assumed rural consumers simply couldn't afford a traditional refrigerator.
Which seems like a safe bet from a corporate office.
Right. But when they deployed researchers to actually study the on-the-ground constraints of rural villages, they realized the problem was vastly more complex than just the sticker price.
The researchers identified a whole series of environmental realities that a Western engineer just wouldn't instinctively consider.
Yeah, they found that families were living in tiny, single-room dwellings. Space was at such a premium that they had to shift furniture around just to roll out sleeping mats at night.
And furthermore, a significant portion of the target demographic were migrant workers who needed mobility.
Add to that the reality of unpredictable rolling blackouts. And perhaps most importantly, they just didn't have the purchasing power to buy a week's worth of groceries at once. They bought provisions daily. They only needed to keep a small amount of milk and a few vegetables fresh for 24 to 48 hours.
So taking a standard 200-liter front-opening refrigerator and simply manufacturing it with cheaper plastics wouldn't solve literally any of those fundamental issues.
It's like trying to park an SUV in a bicycle lane.
Exactly.
The traditional refrigerator was just the wrong architectural paradigm for the environment. It's bulky, it's incredibly heavy due to the compressor, it requires a constant draw of high-voltage power, and its capacity far exceeds the daily need.
So Godrej had to apply constraint-based design from the ground up. They developed the chotuko. They immediately changed the orientation. Instead of a front-opening door which allows all the dense, heavy, cold air to spill out onto the floor every time it's opened, the chotukool opens from the top like a picnic cooler.
Because cold air sinks. That one architectural change massively reduces the energy required to maintain the internal temperature.
Right. And to address the rolling blackouts, they integrated a rechargeable battery system. But the most significant innovation was how they generated the cold air in the first place.
The compressor.
Yeah. They realized the compressor, which is the heavy, loud mechanical pump circulating refrigerant gas, was the central point of failure. So they eliminated the compressor entirely.
Wait, how do you have a fridge without a compressor?
They replaced mechanical refrigeration with solid-state electronics.
Oh, they utilized a thermoelectric cooling chip.
Yes.
This relies on the Peltier effect, right? When you pass an electric current through a junction of two different conductive materials, it creates a temperature gradient. One side of the junction gets hot, and the other side gets cold.
Exactly. It essentially acts as a solid-state heat sponge, absorbing heat from the inside of the cooler and dissipating it outside.
And it is the exact same high-tech component used to cool advanced computer processors.
Isn't that wild? By replacing a complex mechanical compressor with a solid-state microchip, the manufacturing implications were profound.
The total number of components dropped from over 200 in a traditional fridge down to barely 20 in the Chutacool.
20 parts.
The total weight dropped to just over 7 kilograms, making it easily portable for migrant workers. The power consumption plummeted to 55 watts, and they brought it to market for roughly $70.
They successfully blended sophisticated solid-state physics with a simplistic top-opening design to completely unlock an untouched market.
And that product demonstrates that frugal innovation requires a fundamental redesign tailored to the specific environment.
Absolutely.
If we extend that logic from the mechanics of a product to the physical materials used to build it, we confront the ultimate environmental constraint,
Industrial waste.
which the sources address brilliantly. They cite a startling statistic from Taiwan. 100 million plastic toothbrushes are discarded every single year.
That's just in Taiwan.
Right. And the synthetic polymers in those brushes take centuries to degrade, and millions inevitably end up as microplastics in the ocean. So a Taiwanese eco-startup called Agude set out to design a 100% biodegradable toothbrush to close this waste loop.
And to achieve this, they utilized a framework that academic researchers call entrepreneurial bricolage.
Bricolage, I love that word. It essentially means making do with the resources at hand.
Exactly. Instead of spending millions in a laboratory trying to synthesize some novel biodegradable bioplastic, you look at your immediate geographical environment and figure out how to recombine abundant local materials to solve the engineering problem.
So Agude looked at the natural flora of Asia.
They identified Moso bamboo for the handle. It's an incredibly fast-growing, highly renewable resource, and crucially, it possesses natural antimicrobial properties, which means it requires zero toxic pesticides or fertilizers to cultivate.
And for the bristles.
Instead of nylon, they source natural pig hair from the Yunnan province.
Wow.
The result is a fully functional product made entirely of naturally occurring composites that will just harmlessly degrade back into the soil. They launched this through crowdfunding, raised over $67,000, and basically proved the market demand for zero-waste design.
This specific example of bricolage actually highlights a critical, often uncomfortable insight from Anthony Kuo's paper regarding modern clean technology. High-tech clean tech has a dark side.
You're referring to the life cycle of the component.
Exactly. Consider the manufacturing process for a state-of-the-art photovoltaic solar panel, or, the aggressive mining required to extract lithium and cobalt for electric vehicle batteries.
Right.
While those technologies obviously reduce carbon emissions during their operational life, their creation and eventual disposal involve toxic chemicals, heavy metal runoff, and just a severe environmental footprint.
But frugal clean tech, by utilizing bricolage and local biological materials, bypasses this toxic life cycle entirely. It represents a much purer, more holistic form of sustainability.
It's an ecosystem approach rather than an industrial approach.
And the paper synthesizes all of this into a concept called the adversity advantage. Organizations and engineers that learn to innovate under severe constraints, whether they're facing a lack of capital, a lack of grid infrastructure, or a lack of refined materials, they develop a unique structural resilience.
They learn to extract maximum value from minimum resources.
Exactly. And consequently, they are far more equipped to survive global supply chain disruptions or economic recessions than organizations that rely on bloated budgets and unlimited resources.
Because when you master the physics of survival on a tight margin, you can weather almost any systemic shock.
Spot on.
So, bringing this all back to you listening right now, look at the systems you manage. Think about your workflows, your corporate projects, or even the physical organization of your home.
Are you defaulting to accumulation?
Right. When you encounter friction, is your first instinct to buy a new software suite, hire a consultant, or throw capital at the problem? Are you over-engineering your life? Ask yourself if you are trying to build a $20,000 mechanical incubator when a $25 thermal pouch would perfectly solve the fundamental need.
I think the most fitting conclusion to this analysis is a concept from Leonardo da Vinci, which the textbook references. He said, "Simplicity is the ultimate sophistication."
Beautiful.
Frugal innovation was undeniably born out of desperate necessity in the developing world to serve the bottom of the economic pyramid. But as our global economy faces looming resource scarcity, critical supply chain vulnerabilities, and undeniable climate constraints, we really have to ask ourselves, what if frugal innovation is no longer just a niche strategy for emerging markets?
Right.
What if the ability to aggressively strip away the non-essential isn't just a survival tactic for the developing world, but the exact requisite blueprint for the future of global human progress?
That reframes the entire technological landscape. The greatest, most impactful innovations of our future likely won't be defined by what we have the capacity to add, but by what we have the courage and the ingenuity to take away. Thank you for joining us on this deep dive into frugal innovation. Keep questioning the complexity around you, and we will see you next time.